Greetings of the day to all the learners of Dr. B.R. Ambedkar Open University. Today we shall be discussing about regression analysis, which is a part of your business statistics course. In one of the previous sessions, we have learned about what is meant by regression analysis, what are the variables which are being used, and how to formulate a regression equation. In today's session, we will try to work out a few problems which are related to regression equation. As you can see, the regression equation x on y has been depicted on the board, where you talk about x as a function of a plus by, where we are talking about expressing x in terms of y. So, here we say that x is dependent on y, a and b being constants. Now, when we are trying to solve this particular equation, we are trying to find out what is the value of x for a given value of y. So, here first of all we need to find out what are these two constants which are there, for which we need to understand these equations where we talk about sum of x, which is equal to whatever is the number of units which are there, Na, plus b sum of y. Similarly, summation of x and y with the constant for summation of y and the constant for summation of y square. These two will help us to find out the constants a and b. This is for x on y. Similarly, for y on x also, where y becomes our dependent variable, we are trying to express y is equal to a plus bx. Again, here to find out a and b, we will be using these two equations. Let us now take an illustration and try to solve this particular equations and try to find out what is the final equation that we would get. Let us assume the values of x as 6, 2, 10, 4 and 8. You can take this as demand or price, and y as 9, 11, 5, 8 and 7. First, we will try to find out the regression equation x on y. So, when we are saying x on y, we are trying to say x is equal to a plus by. Here, we need to find out all these values. So, let us now take what is the summation of x. So, add up all these values, we will get summation of x, which is our first variable here. So, 30 we get. Similarly, summation of y, we get it as 40, multiplying x and y. So, the product of x, y, 6 into 9, 2 into 11, 10 into 50, 4 into 8, 8 into 7. We get all these values, which is summation of the product x and y. Similarly, you have to square variable x and square variable y. So, you get x square and y square. So, 6 into 6, 36, 2 into 2, 4, 10 into 10, 100, 4 into 4, 16, 8 into 8, 64. Similarly, 9 nines, 81, 11, 11, 121, 5 and 5, 25, 8 and 8, 64, 7 and 7, 49. So, when we get all these values, let us take summation of each one of these columns which are there. So, summation of x, column x, summation of column y, summation of products of x and y, summation of x square and summation of y square. Once this table is ready with us, we shall start substituting these values into the equation now. So, let us see the equation. First one, sigma x is equal to Na plus b sigma y. So, here it is 30. We calculated summation of x, which came as 30. So, 30 is equal to n. N here are the number of units. So, 1, 2, 3, 4, 5. So, 5 units we are explaining. So, n is taken as 5. So, I have put n as 5. A is what we are trying to find out. So, A is written as it is. Now, summation of y, we have did summation of y, which is 40. So, we have kept 40 here, and b is what we are trying to find out. So, this is our equation 1, where we have said summation of x 30, n is 5 number of units. So, 5, a as it is a, b is b as it is, we are trying to find out that, and then summation of b, which is 40. So, we have substituted and got equation 1. Same way, get the second equation, which is summation of the product of x and y. So, summation of the product of x and y 214, which we worked out here, product of x and y, we got this as 214. So, here 214, and summation of only y was 40 and y square was 340. A and b is what we are trying to find out. So, this second equation gives us these values. Now when we have to solve these two equations. So for us to solve these equations, there should be something in common. So for something to be in common, let us see which one can we find out first. So here let us go for multiplying equation 1 with value 8. So when we multiply, this will become 5 into 8, 40. So that this and this can be eliminated in order to get B. So what are we trying to do? Multiply equation 1 by 8. We will get 30 into 8, 240, 5 into 8, 40. 40 into 8, 320. This is our new third equation which will come into picture here. Now we will try to solve equation 2 and 3, where we are trying to see equation 2, which is 214 is equal to 40a plus 340b, and the new equation which we got after multiplying with 8. So once we solve these two equations, the value that we get will be 26 is equal to minus 20b. Now here if you see, we eliminated a. We eliminated a from here because we wanted to get only 1 first. When we get 1, when we substitute back, we can get both the values then. So first let us find out b. So we eliminated a, now we will try to find out b. So now we got the value of b. With this value of b, we will substitute that value in any equation. So let us take equation 1 and we are substituting that in equation 1. When we solve all this, we will get value of a also. So we got value of b. By applying these equations, eliminating a, we got b. Substituting b back in any one of the equations, we will get the value of a. So when we get a and b, now we have to get back to this particular equation we are solving. We should remember that we are solving x on y. So when we are solving x on y, we are trying to get this particular equation. So here x will be equal to, we got the value of a and also we got the value of b. So x now is expressed as 16.4 minus 1.3 y. So here if y is given, say for example x is demand for a product and y is price. If price is given as 3 rupees, what will happen to demand? Then we will say x is equal to 16.4 minus 1.3 into 3. So we will get units demanded for a given price. This is how we work out a simple linear equation where we are trying to find out what are the values of x on y. Same way we can also do y on x with the same variables which are present here. Simply that here we have to substitute wherever we took y here, because y will now come on to the left hand side. So your right hand side will become x now. So when we are trying to solve the other part where we say what is y on x, we are saying for y on x, this working out which we did was for x on y. Now when we are saying y on x, we are trying to basically say this particular equation. We are trying to basically find out sigma y is equal to na plus b sigma x, and sigma xy is equal to a sigma x plus b x square. So you see here, the moment I have taken y onto the left hand side, on the right hand side you will have only x. X will help you to determine y. In the previous one we had here x, so all the values were related to y here. Now we have y here, so on the right hand side you will have all values related to x, which means x is helping us to find out y. So now again we will get all these equations once again. New equations will come to us by substituting these values, through which we can get the values of the other. So you see, summation of y is 40. So in this equation I put it as 40. N is your 5 number of units. A we don't know, so we write as it is. B we don't know, that summation of x is 30. So this we will get as equation 1. Similarly, if we solve this, we will get 214. A we don't know, so put it as a, and sigma x was 30. So 30a plus b we don't know, so put it as, numbers always comes first, so put it as b, and x square summation was 220. Again the process remains the same. We try to eliminate any one, a or b, so that we get the value of other. So if you see, what can we eliminate? This is 30 here and this is 5. So we can multiply this equation with 6. So 5 6 becomes 30. So this 30 and this 30 gets eliminated. with the help of which we can solve this equation, get the value of b, substitute value of b back in any one of the equations so as to get the value of a. Once we get a and b, then we substitute in our original equation where we talk about y is equal to a plus bx, and then that will help us to find out the value of y and x. This is what is your simple regression equation. But all this is a lengthy process, and as a student it would always be better to find out, can there be any other means of doing this particular thing. So then comes the second method of finding out regression values or finding out values for regression equation, where we are talking about finding out these values from two things. One can be actual mean and one can be assumed means. So regression values which we will find out from mean, and this will be your actual mean, or regression value from something called as assumed mean. So from two things we can find out. So here what are we taking? We are trying to take deviations from the mean. Here what have we taken? We have only simply multiplied and taken squares of it, but now we will try to understand by taking deviations from that particular mean if we go by the same example. Just thing is that the formulas which will be applicable will undergo a change because we are talking about getting mean into picture there. So let us try to find out what those formulas are. So here we will talk about one more illustration which we can talk related to means. So here we can say x on y, where we will talk about equation will be. Now here comes your standard deviation, because we are taking deviations from mean. So this is how the regression equation looks like. So x on y will look like deviation of x from mean of x. Then there are standard deviations of x and y, deviation of y from mean of y. This is how we will try to find out by taking into consideration actual mean. So this is the formula for regression which is related to the actual mean which will be there. So when we take actual mean, that is mean of the values. Mean is nothing but arithmetic mean. So when we take arithmetic mean, which is also expressed as average, so then we will take into consideration this particular formula. So here you see we got a new thing, standard deviation here. So how do we write this particular standard deviation? This is nothing but summation of xy and summation of y squared. This is for x on y. Similarly, if we want to take y on x, because variables can be interchanged, when we want to take y on x, we are taking deviations of y from y mean, that is the mean of y, and then we will take standard deviation of y. So you see the numerators changed there. Here we took deviation of x when x was on y. Here we took deviations from y. So your left hand side is different here. Here x on y means we are trying to find x. So deviation of x from x mean. Here y on x. So we are taking deviations of y from y mean. Similarly, standard deviation. This symbol represents standard deviation. So when we use this particular symbol here for standard deviation, if you see the numerator here, when we are saying x on y, the numerator should have standard deviation of x and denominator y. When we say y on x, here the standard deviation will come for y in the numerator and x will become the denominator there. Then we close it with x minus x bar. This is how we try to say x on y and y on x. And here also when we are trying to find out this, that is this portion of the formula, because this is simple, y minus mean, x minus mean is simple. What is new is this part. So this portion which is new to us, this when we are trying to find out, this is nothing but sigma xy by sigma, it will be x square now. Here it was y square when we were saying x on y, because we are trying to find out x, so here it will come y. Here now we are trying to find y, this will be x square in the denominator. So that way this particular difference has to be noted by the students here. Now let us take the example and then try to solve this particular problem of arithmetic mean using the example there. So here if we take you have to draw the table again here, taking into consideration all the deviations which are coming to apply this particular formula, but working out will be a little easier because you don't have to solve equations, get the value of one and substitute in the value of another. Directly we can work out and get the values. So, let us take one example and then try to solve this particular problem. So, here you see x and then I write small x because this is x minus x bar. Then I take x square, then I take y, then I write small y which is y minus y bar is nothing but mean. Then I take y square and finally x and y. So, if the values of x 6, 2, 10, 4, 8, for these values of x, now let us see first summation. So, sigma x is 30. How do we get x bar? X bar is nothing but mean. Mean is what? Sigma x by n. So, sigma x is 30. N is number 1, 2, 3, 4, 5. So, 30 by 5, 6. So, sigma x which is x bar is 6. So, here now what I will do? X minus 6. So, here it will be 6 minus 6. So, 0. Here it will be 2 minus 6. So, 2 minus 6 minus 4. 10 minus 6 plus 4 minus 6 minus 2. 8 minus 6 plus 2. This is how I am getting deviations. In the earlier one, in simple regression, we did not take these deviations, but here we are taking the deviations. So, here now this is x square. This will usually be 0 because there are positive values and negative values which are there. So, 0. Now, square of this. So, square of 0 is 0 only. Square of minus 4 will become plus now because minus into minus is plus. So, 4 into 4 16. Similarly, 6 into 6 36. 2 into 2 4, 2 into 2 4. So, this will become plus. Now, we say sigma x square. So, add up all this, then you will get sigma x square which we got as 40. This is related to all x. Now, go to y. So, let us see the values of y 9, 11, 5, 8, 7. So, take the totals of this. So, sigma y 40. Now, first we will get deviations for which we need mean. So, here it will be sigma y by n. So, sigma y was 40, number same 1, 2, 3, 4, 5. So, divided by 5, this is 8. So, now take deviation. So, this will be y minus 8. Earlier it was x minus 6 because mean x was 6, mean y is 8. So, we will take y minus 8. So, 9 minus 8 plus 1, 11 minus 8 3, 5 minus 8 minus 3, 8 minus 8 0, 7 minus 8 minus 1. Take the totals of this, this also will be 0. Now, y square, squaring all these values, 1 into 1 1, 3 3 is 9, 3 3 is 9, minus will become plus 0 and this will be 1. So, y square 18, 19, 20. So, this is 20. Now, multiply x and y. So, this and this we are multiplying now, which is the last column. So, 0 into 1 0 and then you have 4 into 3 12 and then you have next value 6 into 3 you take into consideration, sorry 4 into 3 again 12, sorry this is 4 into 3 12 and then you have 2 into 0 0, 2 into 1 2. This will give sigma xy which will be minus 26. So, values are there, this is minus, plus and minus. X and y. So, this column, these two columns we are multiplying. Now, we got all the values which we need for this equation. So, if we solve this, we got all the values which are necessary in order to solve this particular equation. So, now if we see here sigma xy. So, xy minus 26, y square 20. So, we got this value. So, this is standard deviations. We got this value minus 26 by 20 minus 1.3. Now, come back to here, we will substitute. So, x minus 6 we got this x bar as 6 and this value we just now calculated minus 1.3 and y minus 8, because y bar we got as 8. So, we are just substituting this now. So, solve this particular equation. So, this will be x minus 6, multiply this, minus 1.3 into y, 1.3 into 8. So, this will become 16.4, this will become minus 1.3 y plus 16.4. When we get x also onto this side and then try to solve. So, x finally will be 16.4 minus 1.3 y. Just solving this, this will be the last step which we get when we solve all these things by taking minus onto this side and x onto that side. Same way we can do for this also. For this, if you see xy again minus 26 and x square 40. So, when we solve this, this will be minus 0.65. So, minus 0.65 we will substitute in this formula and then try to find out. So, here what has happened, we have simplified the process. We have simplified the process by simply taking deviations from the mean. So, just take a total of this and the deviation, so that the lengthy process of substituting A into B and then cutting out A, finding B, then substituting B in an equation, all that is gone, which we did in the simple linear one. Here we have simply taken deviations from the mean and tried to solve this particular equation. This is one way of doing, where deviations are taken from the actual mean. Similarly, I don't want to take deviations from actual mean, but I want to take deviations from something called as assumed mean. Sometimes when series are given to us, from those series we can also assume and say that mean can be not 6 but 5. We are assuming this. Similarly, we are assuming mean is not 8 but can be 7. When I am making assumptions, then I will take deviations from that assumed one. I am not taking deviations from actual, but I am taking deviations from the assumed one. So, when I take deviations from the assumed one, then you will have one more step to go, where that particular deviation also has to be taken into consideration. This was the second way of solving a regression equation, where we are trying to solve using arithmetic mean. First one was where we solved using linear equation. Second one where we are solving using arithmetic mean. Now, let us go to the third one, where we are solving using assumed mean, where we are assuming a particular thing and trying to make solutions for that regression equation. So, let us see how the regression equations look like when we take deviations from an assumed mean. So, let us take same values of what we took for x and y and then try to see how it works there. So, assumed mean, deviations are taken from assumed mean. Now, when deviations are coming from assumed mean, you get it as R, deviation is taken, and here y minus y, formula remains the same, but how do we get this? This changes because this is coming from assumed mean. So, here this goes like this. So, this is how you represent deviations from the assumed mean. The formula looks lengthy, but when we solve, it becomes easier for us to solve. And here when we say deviations, this is x minus a. A here is assumed mean. This is for x on y. X is on the left hand side, which we are trying to find, and y is on the right hand side. So, x on y. Now, here what happens, you see, this deviation is coming into picture, d is coming. In earlier one, when we had actual mean, d was not there. We only took sigma x y and then we said sigma x. But here d is coming to picture because we are taking assumed mean. So, when we take assumed mean, this is how the formula comes into picture. So, the same variables, if we take the same values which we took earlier and try to take the deviations from those value, let us see how this works out. You can work out simultaneously for y on x. I shall work out for x on y. Simultaneous working can be done for y on x, which you can find out. So, let us take the values now. Now, let us assume let assumed mean be 5. So, when assumed mean is 5, what will happen? This is for x and 7 for y. So, we are assuming means like this. So, here x will be 6, 2, 10, 4, 8. Now, I am taking dx, which is deviation from assumed mean. So, 5 is the deviation. So, 6 minus 5, 1, 2 minus 5 minus 3, 10 minus 5 plus 5, 4 minus 5 minus 1, 8 minus 5 plus 3. So, I have taken deviation. Then I am squaring these deviations, and then I am squaring 1, 9, 25, 25, 9. Then I take the values here. Sigma x 30, deviation of x 5, squared deviation of x 45. Same way I will do for y also. So, y minus 7, because I took assumed mean as 7. So, here when I am taking values for y, 9, 11, 5, 8, 7. So, now y minus 7, 9 minus 7 plus 2, 11 minus 7 plus 4, minus 2 plus 1 and 0. So, here I will take sigma y is 40, dy is 5, and then I will take into consideration squaring of this. So, 2 into 2, 4, 16, 4, 1 and 0. This will be deviations, squaring the deviations, which will be 25, and the last one where dx and dy. So, this and this I will multiply, dx and dy I multiply. So, 1 into 2, 2, 12, that is 4 into 3, then 5 into 2, 10, and 1 into 1, 1, this will be 0. So, here dx, dy 21. Now, all the values I will just substitute in this particular thing. So, if I substitute, I shall try to get the equations there. So, when I am substituting, let us check here this one. When I am substituting, n is 5. So, first I will take into consideration all the values 5, sigma dxy. So, what did I get as dxy? 21. So, minus 21, dx is 5, dy is I got dy as 5. Then denominator n 5, square of d, I am getting 25 there, and then you have dy, dy is 5. So, 5 square. So, same thing in this formula I substitute like this, and then finally I get the value of this as minus 1.3. So, here I take this back to this equation, and then I put it as x minus, I am assuming mean as 5, and this value just now I got minus 1.3, and y I am assuming as 7. So, now you try to solve this, you will get values of x and y. This is how you will take from deviations, where we are trying to find out x on y. Same way y on x also you can do, where y will come on to this side and x will come on to this side. Similarly, y will become numerator, x will become denominator, and all these values also will undergo change respectively depending on what variable is x and what variable is y. So, here we try to solve 3 set of problems. Problems related to simple linear equation, where we try to directly take x and y, x square y square multiplied. Second type of problems, where we try to take deviations from actual mean, whatever is the actual mean, and then the deviation taken from that, where we try to see whatever are the respective values of x, took deviations from the mean of x, and then solved that particular regression equation. Third set of problems are related to taking deviations from the assumed mean, where mean is not actual, but we have made an assumption related to the mean, and from that particular assumed mean we took deviations. Because deviations are from an assumed mean, that is why the new d element comes into picture there. That is how these 3 set of problems are related to problems which are solving the various regression analysis, where we try to get the values of x and y. These are the set of problems which you will try to work out related to regression analysis. Thank you so much.